then that's what led me to the secant and cosecant. So they look like these little parabolas kind of jumping around, alternating. The gaps that are right here are also places where it's undefined. You know, the only thing that has a domain that's all real numbers is sine, cosine. That's it, sines and cosines. All the other ones have places where you can't use certain values, and that's representing or being represented by the vertical asymptotes. So the way I teach these is I say draw carefully and lightly the reciprocal function of it. So if I were going to do this, the cosecant, the reciprocal is sine. Cosecant, the reciprocal is sine. So I start off drawing the sine function up, for instance, what? Okay, fine. I make that y equals 2 sine of x minus pi over 4. So I start off drawing that, and it turns out, and I'll kind of demonstrate it here. It turns out that on the sine function here, right where there's peaks and valleys, right there, and then halfway in between would be intercepts. When you do your sine, you can see the red dots. I think maybe. So if you can think about the red that I'm just sketched in, and if I did that first, then wherever the x-intercepts are, that's the first thing I would do. Wherever the x-intercepts are, it'll be like right here, here. I would draw vertical asymptotes right there. The reason for that is, let's see, this would be, if you think about it being 0, the reciprocal of 0 is undefined. I'll say it again. If the output right here is 0, 0 over 1, the reciprocal is 1 over 0. It's undefined. So I would have drawn in like this, walls. I would eventually have erased all the dotted stuff here, but the walls would be in place, just as a guide. And wherever the peaks and valleys are, so there'll be a peak right here, the parabola exists, or this little curvy thing, part of the secant or cosecant. So I would make it get up to the walls. You don't want to go through the walls, and keep doing it low and then high and low. And then I'd erase the sine curve, because really what you want is the cosecant. And then you're done. So that's the way I'm approaching this. So here's the two problems that I'll do. Not that one. No. Try that again. Okay, here it is. And I'll do it on separate pieces of paper rather than the heavy grid right here. Separate pieces of paper. Okay, let's see. So I still want to identify amplitude, period, all that stuff. So what I'm doing is I'm graphing y equals 2 sine. That's the reciprocal of cosecant. And amp is equal to the number 2. Remember, it's the absolute value of the A. Okay, sure, it's 2. Period. It is equal to 2 pi divided by b, which is 2 pi divided by 1, which is 2 pi. Where's the 1 coming from? It's right here. That's your B. And then what I did is left. Okay, take the argument, which is x subtract pi over 4, set that equal to 0, and then do your right. Same argument, but make that 2 pi. See the distance between 0 and, well, at the end, the distance between the left and right had better be 2 pi. There's a shift, there's a transformation of pi over 4 to the right. So my left endpoint, right endpoint gets shifted. Instead of being 0 and 2 pi, gets shifted to the right. And you do it by adding pi over 4 in this case to both sides. So pi over 4 and over here. Sure, you know, add another pi over 4 over here. So there's 8 of the pi over 4s plus another one, 9 pi over 4. Two periods right here. So this will give me 1 period when I do this. So that's 1 pi over 4. So pi over 4. 2 pi, 3 pi, 4 pi, 5, 6, 7, 8, 9 pi over 4. So 9 pi over 4. Amplitude is 2. So let's say here is 2 and there is -2. The little imaginary box, if you're thinking about that, would be like here. Of course, the box isn't part of the graph, but it just helps guide me with, I wish I had a pencil. Math class without a pencil. Yeah, well, everything I do for you guys have to be in pen. Oh, I do have one pencil here. Everything I do for you has to be in pen for you to see it clearly on the machine. But in the math class, you do it in pencil. You make a mistake, but okay. Oh, this is a sine, a cosine. All right, so you'd say, well, shoot, where does it start? Start with pi over 4 and see where your dot is going to be if you wanted to do it that way. So pi over 4 minus pi over 4 is 0. Then you do sine of 0 at the end. So sine of 0 is 0. Oh, 2 times 0 is 0. So it's going to go like here. Pi over 4, it's 0. And then it goes here. And then halfway goes there. Now, if you're not seeing the pattern the past day and a half when you've been doing your homework, there is a pattern to it. That sine is always going to be x-intercept, x-intercept, x. It's not going to be high, high, and low. That's the cosine. X-intercept, x-intercept, x-intercept. Halfway in between, which is right here, is going to be high. Halfway in between here is going to be low. Now, if you don't believe me, then check it out. Oh, let's see. That would be what, 5? 1, 2, 3, 4. That's 5 pi over 4. All right, check it out. Put 5 pi over 4 back up to here and figure out what that yields. Okay, 5 minus 1 pi. 5 pi minus 1 pi. 4 pi. 4 pi over 4 is pi. 4 pi over 4. 4's cancel. Pi. So what's the sine of pi from the wheel? Sine of pi is going to be 0 again. And then 2 times 0 is 0. So it's true. And then what you can do is then that's 1 period. Now that's a pencil. I'm going to erase that eventually. That's pencil, erase it, because I'm just drawing the sine. I want the cosecant. And that's only 1 period. Now to do a second period, I'm going to go left this time. To do a second period, I'm going to choose to go this way. remember it's the period is still 2 pi. That came from up here. The period is still 2 pi, which is in terms of fourths, because that's what I'm looking at, it's 8 pi over 4. So 8 of those tick marks. Okay, starting right here. I'm going to go 8 this way to the left. Okay, so here's one of them. There's a second. There's a third. There's a fourth. There's a fifth. There's a sixth. There's a seventh. And there's an 8th tick mark. Now I just have to label them. Pi over 4, 0, negative pi over 4, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So negative 7 pi over 4 is way over here. Now I'm going to make my little imaginary box just for a guide. In theory, this all the dash stuff and the pencil is going to go away. So I've already got a pencil mark right here. The other pencil mark should be right here and right there. You know, halfway. So let's see. Maybe that's not right. I think it's right here. Watch how I count. I'm just going to go in by 1, in by 1, in by 1. Yeah, that pencil mark should be right there. So in by 1, in by 1, in by 1, in by 1. Okay, right there. And then halfway should be high, and halfway should be low. Okay, there's 2 periods. Now, I will, yeah, I guess in blue, make my vertical asymptotes. Because those, I'm going to let those remain. I'm going to check this in the calculator too. I might require, hey, give me a window feature that would produce the picture 2 periods with only the parabolas. You know, it's basically the cosecant curve. Give me a window so that on, you know, if you gave it to me, or if multiple choice, you pick the right window. Which one of these windows would actually produce the picture you're supposed to have? Or which function produces the picture? That's probably what the choice that I have for the test bank. On the group quiz, I would expect really nice graphs and labeling, you know, like your markers, some markers like this, you know, showing me how you determine all this stuff is going to be important on the group quiz. And you will typically get a few to choose from. You don't have to do them all to turn them in. So wherever there x-intercepts, that's going to be where the vertical asymptotes are. How do you know, Jeff? Well, watch this. How do you know? Let's see, that's supposed to be negative 3 pi over 4 right there. So the original, okay, that's negative 3 pi over 4. The original looks like the following. That would be y equals 2 cosecant of negative 3 pi over 4 subtract pi over 4. This to be y equals 2 cosecant of negative pi over negative 4 pi over 4. Negative 3 minus 1. Oh, that's negative pi. So on the wheel, where the heck's negative pi? On the wheel, let's see. Negative pi. Now, negative goes this direction. Okay, I'm stopping right here. All right, let's see. I'm thinking cosecant. That's what I'm looking for, which is the reciprocal of sine. Which number is the sine? Oh, 0. What's the reciprocal of 0? It's 1 over 0, which is undefined. Okay, so that just confirms undefined means vertical asymptote. That's a wall. You can't have your graph that I'm going to do heavily in red cannot go through, cannot touch anywhere along the y-axis here, this y line. Can't. Same with this. Same here. In here. All right, so now the little box, I'm just going to make it go away here. The little dot, dot, dot. And the curve is going to look like this, touches, turns. Okay, a top and a bottom parabola is a period. Those two curvy things go together. That's one period. There's two periods. So I've got two periods, and the pencil right here, I just erase and make them go away. Same thing on the group quiz, just erase it, make it go away. Yeah, not bad. Okay, now I take my graphing calculator. Try to emulate the red curvy things. Now what I have to put in the calculator is not the sine. What I have to put in the calculator is the cosecant. So I'll move this up here like that. This right here. Now the only way that I know how to do it, well, there's a couple different ways of doing it. I'm going to do it as 1 over sine. Okay, I'm going to have to write that out. The 2, you're not going to make the 2 go down the denominator. Let me turn that off just. The 2 doesn't go in the denominator, only the sine part. What I'm going to put in my calculator is y equals, okay, that'd be 2 over sine of x. Okay, that's how I'm going to type it in my calculator. All right, pi. All right, now window. I'm going to go window here. Oh, before window, I need to check my mode. Sometimes I forget. I need to check my mode. Yeah, I'm in radian, and that's what I want. You know, that's radians, not degrees. So I'm good. That's good. Now I'll do my window. Now to determine my window, I'm going to go back to my graph that I did by hand. I'm going to go from -7 pi over 4 to 9 pi over 4. So I'm going to go -7 pi divided by 4 to 9 pi divided by 4. And scalar, I'll do pi's over 4. It seems to make sense since everything's divided by 4. So pi's over 4. Okay, y min, y max. You might think -2 to 2. If you did that, you wouldn't see anything because the pictures go farther down and farther up. So you need to have something reasonable beyond -2 to 2. How about leaving it the way it is, -10 to 10? I'll go ahead and do that. So I'm leaving it as is. Keep my fingers crossed. Fingers crossed. Press. Yep, pretty good. The other one, very similar, except it's a reciprocal of secant is sine. I said it wrong. The reciprocal of secant is cosine. I said it wrong. So again, I'll do it on a separate piece of paper. Oh, 3 periods right there. Okay, let's see. So right in here is going to be 1 period. Gets a little messy. Okay, I'm going to do a 1 period this way. Remember, 3 periods. I'm going to do another one this way. And do another one to the right. and then one over here to the left. So it's in terms of sixths. 6 tick marks to the right and 6 tick marks to the left. 6 more tick marks. If I had 6 more tick marks, that would be 11 pi over 6. Ultimately, 6 more pi is over 6. Okay, so there's 5, there's the number 6, 7, 8, 9, 10, 11 pi over 6. 11 pi over 6. Okay, this way here. So -6, negative pi over 6, and I subtract 6 pi over 6 to go the other way. Sounds like it's going to be -7 pi over 6. Just count out 6 tick marks. Okay, so here's 1, 2, 3, 4, 5, 6 more tick marks. Okay, so where am I? -2, -3, -4 over 6, -5, -6. So that is -7 pi over 6. Okay, now I've got my 3 boxes, and a little more complex, a little harder one. If there was a negative out here in front, right here. Remember, negatives cause it to be reciprocal. That's a little bit more complex. There's no negative here. All right, so that means right there and right there and halfway in between. Right there, halfway in between. 1, 2, right there, there. 1, 2, okay, since there's no reciprocal, I would still go up and down. If there was reciprocal, I go down and up for the, oh, this is a cosine, my mistake. I almost forgot. Remember, this is a little think bubble here. I'm going to draw my y equals cosine, blah, 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 blah. It's a cosine, so it starts high. Doesn't go there. So I apologize for that. Good thing I caught that. I mean, it's a good thing to maybe try and test things out, like -7 pi over 6. It's a good thing to do that. So -7 pi over 6. So pretend this is a cosine. -7 pi over 6, I guess 7. Okay, that gets, let's see, it should be easier. -7 pi over 6 then. Oh gosh, you want to see me do that? I know you do. Okay, fine. Oh my gosh. Cosine. All right, so 2 times -7 pi over 6, and then I just want to make sure at the end it becomes 0. pi over 3? Yeah, pi over 3. So that cancels. That's a 3. So -7 plus 1 is -6. Cosine of -6 pi over 3, which is -2 pi. Yeah, and negative, I said 0 earlier, it's not right. -2 pi. Cosine -2 pi is the same as cosine of 2 pi, which is 1. 1. Yeah, that's what I wanted, was right here at 1. Ultimately, it's supposed to be a 1 anyway. And then up here, and then halfway is low, halfway here is right in between, halfway here is right in between. So cosines have this look. That's a cosine. I'm going to show you back in a picture on the packet what the cosine is supposed to look like. The cosine is supposed to look like this. That's a sine. I was doing cosine. Cosine. How come I'm doing cosine? Because I've got a secant. They're reciprocals. These are reciprocals. That's why I'm doing the cosine. Okay, keep doing it. Here gets a little hard right here to see. Don't forget the origin right there is a tick mark. Okay, so you go here, here, right here, halfway in between. Okay, halfway in between is right here. Halfway in between is right here. Okay, right here. All right, now wherever there's x-intercepts, it's always the vertical asymptote, and I'll do that in my blue pen because I'm going to erase all the dotted stuff and the pencils in a second. Well, a few seconds. Well, maybe a minute or two. A lot of dotted stuff here. Okay, I'm gonna erase all my little boxes here. Red pen. I think you can see here it's going to go like that. But what happens over here, you're only going to go halfway. From here, you're only going to go halfway. So it's like a half a parabola. The other half is way over here. The other half is way down here. So together they make a full upper half of a parabola. And then you go like this, and you go like this, and so on and so forth. Erase the pencil marks, and you got what you needed. And if you want to check it out with your calculator, equals, okay, what am I graphing? A secant. A secant. That's 1 over cosine. So 1 over cosine. So 2x plus pi over 3. Yeah, I want this, except it's 1 over that. Yeah, that looks good. Now I'm not going to hit zoom standard or graph. I want to change my viewing screen so it goes as far left as -7 pi over 6. So negative 7 pi divided by 6. And as far as 11 pi over 6. Pi over 6, not that, but pi over 6, maybe. And I'll leave it as -10 and 10. And hit the graph, keep my fingers crossed. Yep, looks like it's good. Looks like I didn't make a mistake. Okay, so let's go back to something. Well, even this one. All right, so this is an old one. Okay, that's part of a function. I'm going into the next section. This is part of a function. Part of a function. It goes on forever. I mean, this is only 2 periods, but if you're going to do that, you go arrow there, arrow there. It goes on forever. Part of a function. Is it 1-to-1? You guys have forgotten this for a while. 10 weeks ago, we talked about it. What does 1-to-1 mean? Does it pass the horizontal line test? What's about the horizontal line test? I'm testing to see if it's got an inverse. Yeah, we're back to inverses again. Okay, for a function to have an inverse, it has to pass the horizontal line test. And if it doesn't have an inverse. If it does, then it's got an inverse. And then I taught you how to find it algebraically. And then we call each function 1-to-1. Call each function 1-to-1. And to verify that they are inverses, use a composition. The composition of both functions produces the letter x every single time. So we did that a while back in chapter 1. This one doesn't have an inverse. So what we want to do is chop off a basic parabola. No. Function, but doesn't have an inverse. If you chopped off a portion of it, like this one here, so they call it restrict the domain. If you restricted the domain, now that parabola has an inverse. And you'd say, well, what the heck is it? And you'd say, well, the original parabola looked like y equals x squared, but then you restrict the domain, you would say, but x has to be greater than equal to 0. And if you did that, then to find the inverse, you go step 1, swap x and y. Step 2, solve for y. Plus or minus. No, not plus or minus. You restricted it. So the only thing you have is right here. All you have to do is just do positive square root, not the negative, because that's not right. Oh, okay. Like that, sure. Step 3 is solve for y. Okay, step 4 is replace x and y. Step 3, excuse me, step 3 is go, let's see, maybe f inverse, that's what it is, of x equals square root. That's what we did. Ultimately, I think this was a step 4. I think I missed a step. Oh, I know what it was. First of all, it was f of x. That's what it was. So the first step was replace f of x with y. Then swap the x and the y. Then solve for y. Then make that y f inverse of x. Yeah, so this is really step 4. And then if you did that, it would be like this. If you graph that, you would, this right here, you would get that, and then the axis of symmetry would be y equals x. And if you take the composition, you get x. So for us, the trig, I want to chop off. Okay, this doesn't pass the horizontal line test. We know that. I want to chop off some of it so that you get possibly a piece that has an inverse. So how about if I chopped off all that except this right here? Yeah, that piece would have an inverse. Okay, how about if I chopped all that off and did it over here? Same thing, that piece would have an inverse. How about there? In pencil, does that look like it's got not pencil, but light. Does that look like it's got an inverse? Nope. How about there? That does. How about there? That does. So there's places where it does, and so we are going to do it here. The reason why we're doing it here is we're going to tie all the inverse functions to the origin. That has no connection with the origin. This one has a connection with the origin. So we're trying to keep everything to the origin, so it's kind of close to the unit circle, kind of blah, blah, blah. All right, so that's where we're headed right here. Okay, inverse functions, 4.7. For a function to have an inverse, it's got to pass a horizontal line test. That doesn't, so we will restrict the domain from negative pi over 2 to pi over 2. So you get that portion of it. And the range is going to be from -1 to 1 still. So a restricted domain and the range is okay. Then what you do is you say, okay, step number 1, you go y equals sine x. These are my steps that I did back in chapter 1. Swap the variables. Okay, swap the variables. Okay, step number 1, fine right there. Okay, number 2, swap the variables. So you got x is equal to sine of y. Okay, now solve for y. Now, just like logarithms, or exponential functions, logarithms, hard to solve back in logs. And if I had x equals 10 to the y back in log chapter 3, that was impossible unless I introduced you to logarithms. Can't solve for y. So same thing here. You can't solve for y unless I introduce you this thing. Number 3, solve for y. Okay, fine. There. Now what, Jeff? We're just going to call it sine inverse of x. It's nothing fancy. It's like exponential. Y equals exponential inverse of x. That's we didn't do it. We called it logarithm. Here we call it sine inverse. It's as if I took this piece right here and moved it over here with the x, and when you move it, this looks like a power. It's not a power. This is not a sine to the -1 power. It's not. Completely different. It's a notation. So when I pull this over here, then this becomes the argument, not the y, and then it's a little notation with the negative, like f inverse, like this. That's a notation. And then in your calculator, you'll notice on your calculator, they have a place for the inverse functions, which, yeah, there's sine, there's cosine inverse, and tan inverse in blue. That's, okay, these are not powers. These are different than, oh, see that right there? That's a reciprocal. That's a power right there. But these are not. So make sure you're clear on that. Hopefully you are. Oh, and then you say, then what, Jeff? Number 4 would be, rewrite that as what? F inverse of x equals sine inverse of x. But this is good enough. You can stop right here because you're going to put that in your graphing calculator if you needed to. And that's what the picture would look like, by the way. That's the inverse. What would the other part look like? It would look like that. That's the original. So that it would pass through, well, not pass through, but have an axis, the symmetry, I should say, the symmetry would be y equals x. Okay, now you know that it, oh, what's the other thing about inverse functions? I'll remind you again when we did them. The x's were the domain of the original. The x's and the y's, they interchange like this. So the x's of one is the y of the other, and vice versa. The y of one is the x's of the other. That's how it works. And if you did, maybe I didn't do this before. Let's do, I didn't do this before. Okay, logarithms and exponentials. Okay, let's do that. Okay, how do I want to do that? No, I don't want to do that. Let's do, okay, let's do an old-fashioned one. Okay, there's my function, phi the inverse. Okay, there's my function. So you go y equals 2x minus 1, swap x and y. So you go x is equal to 2y minus 1, solve for y. Okay, add 1 divided by 2. Okay, so add 1 divided by 2. Okay, now go f inverse. So you go f inverse of x is equal to x plus 1 over 2. Now, here's the thing about the composition, because I'm leading up to the trig. If I do f of f inverse of x, hopefully remember that's just the argument x. So if I did f of f inverse of 2, the answer better be 2. The answer better be 2. No, well, okay, so how do we do that? You go f inverse, put in a 2 first of the inverse right here. Right here, put a 2 right there. And put a 2 right there. So 2 plus 1 is 4. No, it's not right. 2 plus 1 is 3. 3 halves. Okay, now you take the 3 halves. That's 3 halves right there. You take the 3 halves and put it in the f function. Okay, put 3 halves right here. The 2's cancel. You got 3 minus 1 is 2. Oh yeah, get back to 2. The point that I'm trying to make is if I go f of x is equal to sine x, and f inverse of x is equal to sine inverse of x. So it won't make a difference of what angle you put in. Say x angle is 30 degrees, then f of f inverse of x, or 30 degrees, will be 30 degrees. At the end. It'll look something like this, f. It'll look like this, sine of sine inverse of something equals a result. So whatever goes here has to come out over here, and vice versa. And you'll see that in the next pages coming up. And I will use the wheel to help me out as well to show you. Okay, we just did the sines. Okay, cosine here. Okay, we chop it off differently than the sine. See, we went from 0 to pi. Now the reason for this is for the sine in what are the quadrants here when it sweeps from negative pi over 2 to pi over 2? What quadrants, there's 2 of them, would I be in on the unit circle going from negative pi over 2 to pi over 2? Anybody have an idea? You have 4 choices, but I need 2 of them. From negative pi over 2 to pi over 2. Which 2 quadrants do I sweep through?
Quadrant 2.
Say it again, Xenia.
Quadrant 2 would be 1. right?
Am I? Oh, here's a circle. Okay, so negative pi over 2 is from here, is from 0 to negative pi over 2. Negative pi over 2 is sitting down here. So from negative pi over 2 to pi over 2, negative pi over 2 to pi over 2. Which two quadrants are those? Two of them. Numbers. 1 and what? What's this one down here? 4. Yeah, 1 and 4. So what this is doing, this is Q1 and Q4. Okay. The same thing here. This is Q1 and Q4. Roman numerals. What two quadrants is 0 to pi? Zero to pi. 0 to pi. Which two quadrants is that? Q7 and Q11. Okay, there you guys. Okay. No such thing. Come on, you guys. Which two quadrants right here? Which two quadrants? You guys, this is way back in chapter 4, section 1. I thought I heard someone trying to say, but
1 and 2.
thank you very much for that answer. There you go. Thank you very much. So this is Q1 and Q2. So why those quadrants? It's because the outputs for each one has both a negative and a positive output. Okay, everybody's positive in quadrant 1. Isn't that true? Yes, it is. Everybody's positive in quadrant 1. Sine in quadrant 4. Remember that A smart trig class right here? A smart. I'm not sure today if you guys are not. You're not responding. Okay, all students take calculus. Let's do that instead of a smart trig class. Let's go. All students take calculus. Everybody's positive. Sine's positive only. Tangent positive only. Cosine positive only. So for sine in quadrant 4, it's got to be negative. So sine is going to be positive here and negative in that one. Cosine. This is the reason why they do the restricted domains. You get one positive answer, one negative answer. Unlike over here, you get a couple positives and a couple negatives. So we want to squeeze it down so it's an inverse function, so it passes the horizontal line test. And we pick these quadrants because this is positive in that one and negative in quadrant number 2. Cosine is negative over here because sine is positive, and positive here and negative there. Now, why is this parentheses? Anybody have an idea why those are parentheses and not brackets right here?
They're not included.
Why are they not included? Okay, let's say we include it. What's the problem with that? Let's say we include it. Don't you guys write that in there, but let's say we include it. That means you're including tangent of pi over 2. You're saying that's okay. What's tangent of pi over 2?
Undefined.
Thank you very much, Zinnia. Yeah, you can't use that. So let's make this go away. So this has to be parentheses, parentheses. Okay. Well, it turns out that for the tangent, here it is right here. Just that middle one is good enough. You see how that passes the horizontal line test? Just that middle one. You got a lot of these little ones, but we picked the one in the middle because it's going through the origin. So negative pi over 2 to pi over 2. That's the restricted domain. Okay, there's your information on the inverse trig functions. Now let's use the unit circle to try to figure out what's going on. Before I do that, if I say if I say sine of 30 degrees equals, okay, this is your X value, and the output's going to be a Y value. X values are angles, outputs, and the Y values are like those real numbers on the curve. Remember that? I mean, for this one here, that's not an inverse, but for this one, you would say 30 degrees. 30 degrees is right there, okay, and it's a Y, so the answer is a half. So for the inverse to work, you'd have to go sine inverse, and you put in the half. It's like you're going backwards or something like that, and you're going to get out 30 degrees. Inverses, the argument, are not angles. Inverses, the argument are the numbers on the unit circle. So if I'm looking at all these are inverses, these are all numbers on the unit circle somehow. I find 1/2 right here. I find 1/2 on the circle. And since it's a cosine, it's the X value on the circle. 1/2. Well, there's a couple places actually. There's 1/2 right there. But guess what? There's another one right here. See, there's a half. There's two places, but only one of them's good. Because for inverse functions, you only have two quadrants that you can look in. Only two. Cosine inverse, am I allowed to look in quadrant 4? For cosine inverse on the previous page, are you allowed to look in quadrant 4? Which two quadrants for cosine?
1 and 2.
Oh, you're only allowed to look here. Well, the cosine over here is -1/2. No, that's the only one that is positive 1/2. So the angle for here would be 60 degrees or pi/3. So let's do degrees for a second. I'll show you how this works. Okay, to prove it to you, if I'm in degree mode, because that's my output, just to check it, if I went into my mode and put it in degrees, easier to see, and then I went cosine inverse, and I put in 1/2, and I hit enter, I get 60 degrees. I don't get an answer down in quadrant number 4. I get an answer that's in quadrant number 1. Okay. Here's another cosine right here. Okay, so these are X values, -√3/2, -√3/2. I'm thinking right here, Q1, right there. I'm thinking over here, Q2, because it's Q1, Q2 for cosine inverses. So I'm looking for -√3/2, -√3/2, -√3/2. Oh, it's right here. Sorry, it's a little blurry for you, but you can see where I'm pointing. So what's the angle right there? 5pi/6 or 150 degrees, 5pi/6. You might wonder, well, what answers do you want, Jeff? Radians or degrees? I don't care. I don't care. Now, if it's a test multiple choice, I mean, you're going to, it's either they're all listed radians or they're all listed degrees. So, I mean, you'll have to figure that one out on your own. But on the homework, the back of the book might give you both versions. The group quiz, you get to pick whether it's a degree or a radian. Unless I say, I want the answers in radians, then you have to follow my instructions. Okay, sine, let's do this one. Okay, this is because it's positive, it's Q1. Everybody's positive in Q1, right there. Okay, √3/2, √2/2 for the Y values. Okay, these are the Y values. Okay, right there, 45 degrees or pi/4. Now 0 is unique. I just have to find the y. Here it is, 0 here. So what's the angle right here for the, well, that I'm pointing at? It's 0 or 0 degrees. Okay, tangent or tan inverse. Remember that's sine over cosine. Sine inverse over cosine inverse. Just think sine over cosine. Just y over x. Y over x. You're looking for the answer outside the unit circle to be the number 0. Y over x. Wouldn't y have to be 0 for to be y over x to be 0? It would have to be this one, y over x. Y over x. This would have to be 0 as well. This one's a little more interesting. Might be making more sense. Think y over x. Think. Negative root 3 maybe over 1. That's one idea. Here, like 0 over 1, y over x. Let's see, negative for that. This is in quadrant 4. That's in Q4. Why did I say Q4? Because over here it says Q4, Q1 or Q4. If it's negative, it's got to be in Q4. Oh yeah, it's negative. So negative root 3 over 1. It'd be that one there. Negative root 3 over 1, y over x. 2's will cancel. So what's the angle right here? This is easy to make a mistake. You're pointing, you're thinking, hey, it's 300 degrees. I almost sound like Brian Regan. Yeah, it's 300 degrees. No, it's not 300 degrees because your answer has to be in between here. Answer has to be in between here. 300 degrees is not trapped between negative 90 and 90. That's the hard one. Oh yeah. Yeah, you can't, even though it's, because it's what's pictured here is 300 degrees. Isn't this the same as negative 60 degrees? Negative pi over 3? Right there. That's another way of looking at it right there. Oh yeah, negative 60 degrees or negative, sure, negative 60 degrees or negative pi over 3. Okay, how are you going to test that? If I go tan inverse of this and look at the answer, let's say it's degrees again. Mode. Oh, yeah, degree. Okay, degree. Okay, tan inverse of negative secant root 3, enter. Oh, negative 60 degrees. You guys can do this. This is just find it in decimal form. Except, and let's see which one do I want to do. I want to do, let's do this one. I'll do these two are interesting. This one's not interesting. Watch what happens here. I'll leave it in, well, let's not leave it anywhere. Let's leave it in degree form. I want the degree output. So for decimal form, it doesn't say radian or degrees. Okay, sine inverse. Sine inverse negative. What quadrant is this one in, by the way, before I, on the unit circle? I might ask that question. Hey, what quadrant are we talking about? 1, 2, 3, or 4? Which quadrant am I in this one? 1, 2, 3, or 4? This is your letter grade. You either get an F or an A.
Is it 4?
Well, I'm asking you, what do you think? It's your grade. Letter A, letter F. Okay, I'll just tell you, it is 4. She's a little gun shy. Yeah, it is 4. Yeah, good for you. Okay, quadrant 1. Quadrant 1. Everybody's pauses quadrant 1. Quadrant 1. So on quadrant 1. Oh, quadrant 4. Okay, so oh, remember, so it's quadrant 4. Yeah, these are negative degrees. So negative 26.74 degrees. That would be the answer. Negative 26.74 degrees. Negative 26. Don't forget the degree marker. If you leave the degree marker off, then you're saying radians to me, and then that's not true. Okay, now the reason why I chose this one is because before I even hit enter, all right, look at this. This value as a decimal, negative 0.45. That's the question is that in the domain of the inverse sign? Is it in the domain of the inverse sign? Here's the domain. Is negative 0.45 in between here? That's why I got an answer in my calculator. Is the number 100 domain of the sine inverse?
No.
So here's what's going to happen in your calculator. You'll say, what happened? What did I do wrong? Nothing, because it's not in the domain. So you get nothing. You would say undefined. It's not defined for 100. It's only defined between negative 1 and 1. Undefined. Undefined. Oh, cosine inverse. Okay, what's the domain of a cosine inverse? Cosine inverse. Oh, same thing between negative 1 and 1. That's just outside. Undefined. You're a little gun shy now. These big. Okay, how about 100, like this one, for tan inverse? Tan inverse. What's the domain for tan inverse? Oh, you get everything. You get everything. So that one's going to be okay. But these two are problems. Okay, here. Okay, these are called compositions. This should look familiar to you. They're called compositions of trig functions. So I suppose, thinking for your exam, it's like, hey Jeff, sometimes I can get by in this world of Zoom and online. Jeff, I got by on my last 2 exams. I got 90 degrees. I got 90% on those last ones. And Jeff, I learned something, but I certainly didn't learn A's worth. I just knew how to do it with a calculator, and it's not like cheating. It's just problem solving. I don't really know if it was class face to face. If it was, which it's not. Yeah, my test would be very different. I'd administer it very differently. You get a part where there's no notes, no calculator. You might get a part where there's no notes but a calculator. You might get a third part you get notes and a calculator. I'd be sitting there watching you, making sure there's no like, oh, what'd you do over there? What'd you do over there? Yeah, but we're not. So eventually the institutions of higher learning, community college, university, eventually will go back to some kind of form eventually. So you got to think, Well, how much are you learning? If you're learning stuff along the way and you're a good problem solver, then I have no concern for you. But if you're thinking you're a computer science major, a math major, a science major maybe, and you really need to know what, like your calculus based stuff, you're just kind of getting by, but you're getting letter grades that are like A's. When you go back and you really don't, those letter grades maybe are not as strong as you thought, and it might be holding you back. I'm not sure. So only you know how to answer those questions. How are you doing? I'm doing good. How you doing? Yeah, I'm doing good. I'm getting it. It sure helps, Jeff, to have notes in a calculator. Boy, it makes all the difference in the world. Yeah, but what if you didn't have that because a different instructor says, nope. Could you still get through it and you know your abilities? So that's all I'm saying. So here, I suppose we can just, I'm pretending I'm you. It's going to be multiple choice. Why couldn't I just plug it in to my calculator and see what happens? And maybe I'll get an answer that matches up. Not a bad idea. Because on a face-to-face, I would only give my students the wheel and problems like this. No calculator, no notes, just the wheel. But you guys have a lot of freebies in my class, and so why not use what you have? I'll just plug this in and see what happens. Plug it in, see what happens. You know, if it says quit or weird outside the domain, that's undefined. You know that. Now, here's the thing you got to be careful of, though, before I even do it. Notice all the, see all these guys right here on the outside? They're regular trig functions. Okay, whatever goes in here, wouldn't the output have to be an answer like a real number? I'll say it again. If it's cosine of 30 degrees, wouldn't that be like √3/2? These will all be numbers that kind of emulate these guys in here. So it won't really make a difference on whether it's degrees or radians, because the output is going to be a real number. Now, if I wanted exact answers, not the decimal, you got to know how to fix that. So let's see what happens. Let's do this one first. Cosine of sine inverse of √2/2. Close. Oops, no. Close, close. Okay, hit enter. Oop. Uh-oh, decimal. Yeah, you need to know what that decimal equivalent is. Shoot. It won't turn it into a fraction. I don't think it, I'll do frac. Watch this. I'm going to do my math. Math. Maybe it does. I don't know. There's a frac thing right here. Will it take that decimal and turn it into a fraction? No. Mm-mm. Well, shoot. You can guess, because the answers are either going to be √2/2, √3/2, or a half, or 0. Or if it's tangent, it's going to be weird. So maybe there's a better way of doing it. Here's my idea. Sine inverse of √2/2. Okay, I got to think, what quadrant can I speak about? This is Q1 because of its positive Q1. So I'm going to look for the y value at √2/2, quadrant 1. Oh, okay, we're right there, √2/2, quadrant 1. Okay, so the angle that it's speaking about is 45 degrees. So this right here can be replaced with 45 degrees. So now I've got a modified problem, which says, well, then the cosine at that same position of 45 degrees is the √2/2, which is right here. Yeah, its cosine is the x value. I didn't get that, Jeff. Yeah, I know that. Okay, let's do 3. Okay, cosine inverse of a negative. Which quadrant am I in? Q what? Cosine inverse is defined for just two quadrants, but I want it to be negative. So which quadrant?
2.
Don't say 1.
4.
What'd you say, Xenia?
I said quadrant 2.
It is quadrant 2. Yes, quadrant 2. All right, so quadrant 2. Quadrant 2. This is quadrant 1. Okay, quadrant 2. I'm going to look for negative root 3 over 2 for the x values. Okay, there it is right there. So the angle that I'm looking at is 150 degrees. Okay, so this is the same as tangent of 150 degrees, and that'll be the answer. So what's the tangent of 150 degrees? Well, from the wheel, I could look at this as y over x. That's what you can do. It's y over x. Don't the 2's cancel? It's y over x. Oh, okay. Well, I'll do it this way. It's y 1/2 over x, negative root 3 over 2. And you take the reciprocal of that, the 2's cancel, and then you get negative 1 over root 3. Which it could be that the answer on the multiple choice version rationalizes the denominator. Yeah, multiply top and bottom by radical 3. So that would be negative root 3 over 3. Okay, let's see if it's true. I'm going to go tan cosine of cosine inverse. I'm doing this right here. Tan of cosine inverse of negative fraction root 3 over 2 Okay, I wonder if that, well, looks good. At least the sign is right. See how that's a negative right there and a negative? Now I just have to see if root 3 over 3 is the same as that decimal. Second root 3 divided by 3. Hey, so it's the same answer. Same answer. I'll do one more. I'll do this one. Okay, so I start inside. Notice what I'm doing. It's like I'm working inside and working out. So start inside. Tan inverse of negative root 3 over 3. So since it's negative, it's quadrant 4. Quadrant 4. So negative. Okay, this is like my y over x. This is y over x, y over x, y over x, y over x, y over x. I zoom in here, y over x, quadrant 4. Quadrant 4, y over x. Well, it's certainly not that one. I mean, that's negative 1. So I'm looking for negative root 3 over 3. I'm looking for root 3 over 3, y over x. So it's either that one or that one. If I did this one, wouldn't that just be root 3? That's just root 3. It has to be that one. It has to be. And so I'm just pointing to right here. It has to be that. So instead of replacing the angle, like I did over here, I just kind of say, well, okay, well, what's the cosine there? I just put 45 degrees. What's the cosine there? I didn't have to put 45 degrees. I just have to say root 2 over 2 is right here. Okay, so what's the cosine? Well, it's over there to the left. I didn't have to do that. I could have came up with the answer because I know what's the cosine of that position. So here we go. What's the secant in quadrant 4 at that position? What's the secant? Now I'm going to circle this right here. I want the secant, which is the reciprocal of, well, it's either sine or cosine. The secant is the reciprocal of the cosine. And the cosine is the x. So I'm looking at the reciprocal of that. 2 over root 3. Should be right. 2 over root 3. Should be. Over root 3. Now this one's a harder one to check because, you know, to type it all in, you'd have to go 1 over the whole thing. It would be 1 over cosine of that whole thing, and it's a little harder to check because you don't have a secant button. But it's not impossible.
Professor,
Yeah, Sam?
I could have done something wrong, but I think I got 2 root 3 over 3.
That's correct. No. You're okay because all I didn't do, but what you did do is that.
Oh, right, yeah.
So you said 2 root 3 over 3 is good. That's a good 3. Sorry. You just rationalize the denominator, and probably the back of the book has your answer. Probably would. If this was face-to-face or even on the group quiz, you don't need to rationalize the denominator for me. I think it's busy work. I think it's just busy work. That's all. But if you want to match the back of the book, you're right. That's probably the answer. And on the multiple choice answers. Okie dokie. Let's do this one. I'll do one of these. These are harder. The reason why are they hard? Because what's inside there, those numbers, are not found on the wheel. Here, I'll show you what I mean. All of these are found on the wheel. These are not. So these are likely the kind of problems that I'm going to put on something on the test, because you just can't put it in your graphing calculator and come up with an exact answer or check it. You can't check it. I mean, I did this in my calculator, got a decimal, maybe work backwards, like especially if it's a multiple choice, work backwards. This one's not as easy to do. So here's an idea. We draw a right triangle in the appropriate quadrant. All right. So cosine to be negative is in quadrant number 2. Like this. Cosine to be negative, quadrant 2. Tangent to be positive, this would have to be in quadrant 1. Let's see, sine inverse to be negative, we have quadrant 4. Okay, now cosine. Think opposite, adjacent, and hypotenuse. Right triangles, opposite, adjacent, hypotenuse. Cosine is adjacent over hypotenuse, adjacent over hypotenuse, adjacent over hypotenuse, and then decide who gets the negative. Negative. Who gets the negative? Hypotenuse never gets the negative. Okay, so this has got to be negative. Of course, that makes sense from the origin to the left, it's negative. Okay, tangent. Tangent. Let's see. Opposite over adjacent. Opposite over adjacent. Okay, that looks good. Sine. Opposite over hypotenuse. Opposite over hypotenuse. Okay, opposite over hypotenuse. That's 1 over 5. Who gets the negative? Well, certainly not that. It's got to be there. Now, you probably have a suspicion that the next thing I'm going to do on all of them is to get the missing side using Pythagorean theorem. And that's true. That's what you need to do. So because of time, I'm just going to pick number 2. And pick number 2. Because you can do, this would be positive here, this would be positive there. I'm pick number 2. So it's 7 squared plus 24 squared is equal to I don't know squared. I don't know. Let's call it R, I guess, in this one. R squared. So 49 and whatever the heck that is. Here. And take the square root of that. I think it's 25. Yeah, I know it's 25. Okay, so R is equal to 25. Plus or minus, yeah, you never have negative with the hypotenuse. So this is 25. I built the triangle in such a way that there isn't an ordered pair, right? Well, there is an ordered pair right here. It's 24, 7 right here. I built the triangle in such a way that I'm going to use right angle trigonometry. So the sine of the right angle of the right triangle, what's the sine? Because I built this using the inside. Now I'm going to attack it by the sine. What's the sine of that triangle? You got 3 numbers and you need 2 of them for a fraction, for a ratio. Sine of that triangle. Okay, I'll just do it. Okay, here's the angle, those angles. Okay, it's always opposite over hypotenuse. That was section 4.2 and 4.3 and 4.4. 4.3, 4.4, opposite over hypotenuse, like SOHCAHTOA. Opposite over, so 7. So the answer is 7 over 25. 7 over 25. Suppose I could check it now. Sine tan inverse. Let's try now. Sine of tan inverse of 7/24. Oh, 0.28. Oh, I wonder if 7 divided by 25 is 0.28. 7 divided by 25. And there you go. There you go. But that would be the answer. I want the fraction answer. Multiple choice will have fraction answers as well. Find the side. This one here, you're just going to do tangent is going to be, what is it? Opposite over adjacent, y over x. So opposite over adjacent, whatever that answer, you need the side to come up with the answer. You need opposite over adjacent. Secant, that's the reciprocal of the cosine. So secant, okay, cosine is adjacent over hypotenuse. You need the side right here. So the reciprocal would be the hypotenuse over the unknown side.
Professor, one thing. How can you explain one more time, like how you got how you knew which quadrant the triangles would be in?
Hold on a second. Let me think about how I'm going to highlight the rest of it from this page. Yeah, this is good. So going back to this, you have to restrict the domain. From the whole start, we couldn't have everything because it had to be passing the horizontal line test. So there's always two quadrants. It's just defined for two quadrants. Everybody's defined in quadrant 1. Now, quadrant 1 means everybody's positive. So what's positive? Well, let's see. That's not positive. Oh, that is. So this is going to be quadrant 1 right there. 7/24 means quadrant 1. That's not positive. Okay. So if it's not positive, then you've got versions or other quadrants. So for a sine inverse, you're in quadrant 4. For a cosine inverse, you're in quadrant 2 for negative. And for tan inverse, you're in quadrant 4. So it looks like the sine inverse and the tan inverses are in quadrant 4. So for negative, okay, like down here, sine inverse has got to be a quadrant 4. Negative for a cosine. Well, it can be 1. Everybody's positive 1. So cosine, a smart trig class. Where's cosine negative here? Well, it's there and there. Oh, but here's the other thing. Nobody is defined in quadrant 3. Nobody. So maybe that's even easier. Forget that. Nobody gets quadrant 3. Nobody. All right. So you look at this and say, well, it's a cosine. Where's cosine negative? Only in one quadrant. Okay, try this down here. A smart, forget that. No. Class. Where's tangent negative? Oh, well, you got a choice. Here or there. Well, that kind of blew my, I thought there would be a simpler way of doing it, you know. Yeah, this is true. Nobody's in quadrant 3. Nobody's in quadrant 3, but here, cosine was positive here, but negative there. Okay, fine. Cosine inverse. The two quadrants where it's defined for is highlighted here. Tan inverse. Sine inverse. Because that's what I'm looking for is the inside. Like, where do I draw my picture? Where do I start looking? It's the same as the tan. Sine inverse and tan inverse, the same two quadrants. There's a slight variation though. You can't, for the tan, you cannot look at negative pi over 2 and pi over 2. You can't do that. But they're still quadrant 1 and 4. I don't know. Does that help, Sam? I mean,
Yes, thank you.
It's kind of crazy stuff. This is new for a few of you. Remember, this course is meant to be a review, so the intent is you've had it before. You just need a little review, and maybe it's been a while for Sam. That's a possibility. Okay. Pictures. I think I talked about in the past angle of elevation and angle of depression. So if I looked at this one's got a little word problem here. Search light. Okay, so this one here is 200. Angle of elevation is 35 degrees. That's 35 degrees right here. They want to know how far is that. So call it something. Maybe since it's going up, let's call it Y. Looks like up the Y-axis. Solve for Y. No, you're assuming, I think all of these problems, yes, all the problems, the word problems in chapter 4, yeah, word problems in chapter 4, they're all right angle word problems. All of them are word problems. So that's nice because you can use the Pythagorean theorem if you need to. Chapter 5, chapter 6, they won't necessarily be right angle, so it becomes a little bit more challenging, but we're not there yet. So if I'm going to do this, right angle trigonometry is just using the cosine, sines, those things that you've had before. So let's see, I want to include what I don't know. The hypotenuse is important for this because if I use two sides, that's opposite and adjacent. What trig function comes to mind with opposite and adjacent? Which trig, opposite and adjacent?
Tangent.
So we're going to go tangent of the angle they give you is equal to y over 200. And then what you do is solve for y. So some of these are pretty easy, straightforward. You just have to set up the equation correctly. Be careful, the 200 doesn't get multiplied to the 35. So I'll write that as 200 tangent 35 degrees. That's probably better for you guys. So, 200. Oh, okay. I pressed the button without checking. See, I'm pressing degrees and I'm always thinking, I'm always in degrees. Not necessarily. I need to check the mode and I didn't do that. So I'm going to do it after the fact. Whew, okay, I was in degree, but you know, the author has a way with the test bank to include a phantom number, which looks like if you put in like radian, for instance, and you do the same thing. And you think, all right, 210 degrees, but it's not. And you'll get that and you'll say, well, there's the answer. It must be 94.7 meters or whatever that is, which is not right. That's not right. It's this one up here. So just be careful. How high is that? Yeah, what is it? I don't know if it's that's weird. 140 feet. Well, I guess it could be fog. 140 miles. Yeah, I don't think so. I'll just put 140. Something. Units of measurement, units. Oh, meters. It has meters. Ah, there it is. Okay, I just didn't see it. Okay, that helps. Oh, meters. A meter stick is about a little more than a yard. A little more than 3 feet. A yard, 3 feet. Oh, okay, that's about 5. That seems reasonable. 500, 600 feet for a cloud cover. That could happen. Low clouds. Okay, famous ladder problem. Every trig class, beginning trig class has a ladder problem leaning up against a wall. Every calculus class, your class, if you take SRJC's Math 1A, that's a pretty standard calculus they call it related rates problem. You look at it differently. If this is a ladder right here and you're pulling the ladder out this way in calculus, this top of the ladder is going down. They'll ask you at what speed, if you're pulling this bottom ladder at a constant speed of 2 inches per second or something like that, how fast is the top of the ladder coming down? And at 10 seconds, where would the top of the ladder be above the wall? Those are questions in a 1A class that you'll ask. But for us, we're just doing trig. And okay, so you have this, you have that, and you want to find out, let's see, 65 degrees. How high in the wall does it? Okay. You want to know like this right here, how high? So letter A. Okay, I need to use the y and the 5. The y and the 5. Okay, that's opposite over hypotenuse, sine. So you go sine 65 degrees equals y over 5. Therefore, y equals this. Squiggle, squiggle. About 4 point, I don't know, you might say, well, where do you route it, Jeff? Wherever it matches the answers in the back of the book. I'll do 1 decimal. I don't know what the back, say again?
What mode are you in?
Degree, it should be degree. I hope I know your degree. Let's go mode. Oh, good job. You caught, who caught me on that one?
That was me, Delia.
Yes, good job. Okay, so she was right. I didn't check. Talk too much. Let's go down here. All right, 4.5 meters. Letter B. How far is the foot of the ladder from the wall? Oh, I don't know. Make this X, I guess. If you knew this squiggle is about 4.5, kind of a crummy approximation would be to square, and use the Pythagorean theorem. You'd be off by some decimals because you've just rounded that. So a better way would be to do what, a cosine? Use the given, which is 5. That's exact. Don't use that. Try to avoid in your calculation using approximating values. So cosine. So let's see, this call it X. X equals cosine. Sorry. Cosine 65 degrees, like up here. Cosine 65 degrees is X over 5. And so X is equal to 5 cosine 65 degrees. Uh, 2.1. And letter C. Letter C is asking what angle. They're wondering what this angle is right here. How might we find it, or what is it?
180 minus 90 plus 65.
Okay, that's one idea. That's good. Okay, how else? That's not wrong. What is the answer? Anybody?
25.
Okay, so here's another idea. That's 9. Okay, the angles, the sum of the interior angles is always 180 degrees for a triangle. Well, if that's 90, wouldn't this have to be 90? The leftover. Yes, that's always true. So you can go 90 minus 65, and it's called, okay, here's a question, could be on the final exam. Supplementary or complementary angles when you have 2 angles add up to 90? Supplementary or complementary?
Supplementary.
Nope, that's adding up to 180 degrees. Complementary is adding up to 90. So if I knew this is 65 plus what is 90, that's kind of what you're doing. Yeah, so, okay, so angle, it would be what, 25 degrees is the angle made with the wall. Okie dokie, let's see, anything else in here? Okay, vertical cliff. Okay, here's my cliff. Here's my cliff. Looks like it's a boat. So water, 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 water. Okay, atop of, okay, this is 100 meters. A ship is spotted at an angle of depression. Okay, that means from here, it's looking down. Okay, the ship's way over here somewhere. Okay, 12 degrees. So angle depression, here's my pen, there's the horizontal, like this. Here's the horizontal. Okay, the ship's up, well, ship could be there, ship over there. I want to try to draw it to scale the best I can. Where do I want, oh, can't even say it. Where do I want to bend this down? Okay, okay, how about there's a ship right there? Does that look like about 12 degrees right there? No, that's way too big. So angle depression, I want to be as close as I can. So it's not very much. I would think that it's a small, I'm looking at the angle right here. Angle of depression is probably about 12 degrees right there. Right there, right there. All right, so, okay, I'm going to try to go like, okay, I think the ship is right about here. Here's my boat. Yeah, that's 12 degrees. And this is the right angle. Okay, here's my right triangle right here. To do any of these problems, you need an angle, not the 90 degrees. You need one of the other angles. Here's the key in geometry. Sophomore, well, they used to do geometry in high school at sophomores. I don't know if they do it anymore. In a high school geometry class, it'll turn out that they have this thing called alternate interior angles in geometry, alternate interior angles. Or you can do this. Okay, what's this angle right here? That's probably even better. What's this angle right here? How do you find that? Let's do that instead.
Would it be 90 minus 12?
It would be, right. Okay, 90 minus 12, that's because that's the complement. This is a right angle. 90 minus 12 was 78. So this is 78 degrees. Okay, we can use that piece. That's fine. So they want to know how far the ship is from here. They want to find here. Let's call that X maybe. So I'm going to use these two sides at that angle. So gosh, that looks like a tangent. We need a tangent. Tangent is opposite over adjacent. This is the adjacent now right here to the angle. So it's tangent of 78 degrees is X over 100. Tangent of 78 degrees is equal to X over 100, and then solve for X. The setup is the hard part. Punching a calculator should be easy. Just don't forget to put it in degree mode if that's what you need. Tangent of what, 78? I'm getting 470. I'll just say to the nearest, what, meter? Mile? Meter. Mile is MI, is the abbreviation. That's meter. Okay, 470 meters. All right. Find the distance from the top of the cliff. Oh, find this. I'll let you do that because it's a Pythagorean theorem. Or it doesn't have to be. Let's see. I can do this. Watch. Let's call that R. That's probably even better because I'm not using rounded answers. Okay, if I need this side with that, and I have this angle, that's a hypotenuse. That's adjacent over hypotenuse, or X over R. Okay, so that would be cosine. Okay, a little bit more work. So multiply r to both sides. So that's r cosine 78 degrees equals 100. And then what you got to do is divide both sides by cosine 78 degrees. You got to divide both sides by cosine 78 degrees. Okay, so r equals 100 cosine 78 degrees. All right, let's see. That should be the longest. Remember, r is the hypotenuse. So that's just a way of checking, maybe. 100 divided by cosine 78. 480. Yeah, 480 is more than 470. 480 is more than 100. It's reasonable. 481. Okay, let's see. Drawing the picture sometimes is helpful. Not is helpful. Draw the picture correctly. Okay, he's lying on the beach, flying a kite. Oh gosh. Okay, here's my beach. I'm assuming the beach is flat. Okay, here's my person lying on the beach. Okay, here's his legs right here. Okay, he's holding a kite way at ground level. It's kind of a weird problem here. Okay, here's my little hand right here. Here's a little hand. I'm holding it to my chest on the ground level. Flying a kite. Okay, so holds the end of the kite ground level, estimates the angle of elevation to be about 50 degrees. Shoot, see that right there? That's about 40 degrees. So it's not very accurate. The concept's the same, but it's not very accurate. I'll say this is 50, but it's not very accurate. I should have thought about that when I drew my line, since I did it in pen. They want to know how far this is right here to the ground. Call that y, I guess. And what do they know? String. Okay, so this is 450 feet long. So what trig? You've got three choices. Which trig function, sine, cosine, or tangent, do you think I might use? What trig function? Sine, cosine, tangent.
Sine.
I would agree. Yeah, it's opposite over hypotenuse. So sine of 50 degrees is y over 450. Okay, and this one's not too bad to solve. Greater than 45 feet. We do one of these. I'm looking at time. One of these, and I need to do a couple of these. So I think I'll do out of the 5 problems. I think there's only 5 left over. I'll do 3 of them. Yeah, 3 of them. Now I had scheduled. I should say I have scheduled, not had. You've got another quiz, but since I went over, it's all about the graphing, but you know, I didn't do all the graphing, and it includes secants and cosecants, things like that. So I'm going to say I'm going to leave the little baby quiz open through the weekend. It's good to practice it anyway. So there is a daily quiz, but it's not just due today. I'll leave it open through the weekend. That gives you about 3 or 4 days to consider it. There's only 5 problems, I think, and it's all on graphing. So there won't be really any time today to do breakout room, people. You'll be on your own unless you have access with talking to each other, because you've developed relationships, friendships, and you can reach out. I'm okay with that. Reach out to each other and say, hey, what'd you do? How'd you do it? But not on the exam. Remember, not on the exam. All right, which one do I want to do? Whoa, let's see. Altitude, angle of elevation. Okay, they're both kind of the same. All right, I'll do this one. Okay, 96-foot tree is a shadow. Okay, I'm going to assume that it's a flat, like level ground. So I'm going to assume a flat level ground. And here's my tree. And it casts the, okay, so this is 96 feet right there. And so I'm assuming also that the tree isn't leaning. That makes it a little more complex. It's growing straight up. This is a right angle trigonometry right now. So I'm growing straight up. Cast a shadow. So where would the sun have to be? What is the angle of elevation to the sun? So I think the sun is over here, by the way. It'd have to be cast in a shadow, so sun has to be on that side. Okay, so let's see. Oh, this is 120 from here to there. And they want to know what the angle of elevation. Okay, so the angle of elevation. Well, is that elevation here? No, to the sun, it's this one here. I want to know what the angle of elevation right there is. Excuse me one second. Okay, so I have two sides. I'm going to use a tangent. Let's call that, I don't know, theta. So it's a little different because it's tangent of theta is equal to 96 over 120. Remember, it's opposite over adjacent, 96 over 120. Now this one's different because I got to find the angle. That means I got to peel off the tangent somehow. You guys remember me doing something like that, or how I do that? Any idea how to solve for the angle? I want theta all by itself. Okay. There's still going to be 96 over 120 on the right-hand side. What's going to happen with the tan? What's going to happen with the tan? You don't divide both sides by tan. That doesn't make any sense. But you do move the tan. You're going to move it over here. What's going to happen to the tan when you move it across the equal sign?
Inverse tangent.
Yes. So tan inverse. All right. So we use a tan inverse. Oh, degree mode would be a lot easier. Look at the mode here. Yes, degree mode. So this will be in terms of degrees, not radians. Quit. Okay, enter. Okay, the angle of elevation to the nearest degree, maybe 39 degrees. Theta around 39 degrees. All right, two more problems. The last two are called bearing problems. Bearing. I was in a plane last Sunday, airplane, little Cessna, and the author, the pilot, he was reading, and I was looking at his instruments too as a passenger. And I was asking him questions. I said, and I also included, hey, in my trig class, we're talking about bearings. He says, well, we call these headings. So what he spoke in his, control tower language is different than what our author does for bearings. It's slightly different. So I'm thinking maybe bearings is all about nautical or navigational with ships. I've got to talk to I don't know, someone who really does a lot of sailing or slash commercial ships or something like that, and see if what we're doing through the author, if it's really what's being demonstrated and done out there in the real world. Because what's doing in the plane, he's not doing it the same way. There is south, west, east, and north. There is all that, but in terms of his directional angle, different. Okay, so I think what I'll do is, let's see, how far is it? Okay, I'm going to do this one and the one on the next side. Now, bearings, if you look at a map, up is north, down is south. That's very typical for forever. Most of you don't look at maps like, you know, AAA, full them all out. Map folding is always an art. How do I put this thing back together? The actual paper maps, kind of a lost thing because you got Google Maps, or you've got whatever topographical satellite map. This is north, and this is south. Over here is east, and here's west. So we have to agree on that in this course. All right. They're asking for what's the bearing. Bearings are is always for our course 2 of these letters. You would never say north south. The winds that have been going crazy, you know, for us, oftentimes they're coming from the north, east, sometimes northeast. Blowing towards the ocean is like coming from the northeast because the ocean's on the west. So I'm going to show you how you speak this. It's going to have 2 letters, always north first and then east and west second, or south first, east or west second, always. And the pilot that I talked to, that was always the same for him too. It was like northeast, northwest, southeast, southwest. It was never west south. I have a west southerly wind blowing. That makes no sense. All right, so just know that you always start with the north, picture-wise, north or south, and then head in the direction of the second letter. So if I said, you know, northeast like this, not this problem, but northeast, and I go 10 degrees, not this problem, northeast 10 degrees. So you're here starting at north and you're heading this direction. So the 10 degrees is up here, not down there. I would say there's always a handful of students that put their angle in the wrong place. I understand, because you're always thinking it's got to be tied to the positive x-axis. Bearings is different. It's the only time that you're not tying your angle that you're talking about to the x-axis, the only time. Hopefully you're not one of those handful of students that's going to get these problems wrong on the test. Hopefully not. So north, okay, so what are we going to do? 87 miles, okay, boat is 87 miles east. Okay, so over here and 29 miles south, you're in quadrant number 4. So 87 miles east this way, like right there, and then 29 miles south, let's say it's right about here. There's your boat. So this distance right here is like this distance here. What is that, 29? Right here. So then you got a right triangle. Okay, so I put in the 2 values. If the boat is heading directly for the harbor, oh, okay, the boat's going this direction. The boat's here, it's going this way. This way, going this way. What bearing should the captain follow? Now, this one's a little more challenging. I might pause for a second, and I'm thinking I should do the one on the top too. Gosh, I'm almost out of time. No, I'm going to do the other one first. So I'm gonna come back to that one. I'll have enough time. Sorry, it's been a long day, but remember I had to wrap up chapter 4.6, I think it was. I'll come back to the other one because I gotta finish it. Okay, shore due north. Okay, from a shore which runs due north and south. Okay, so here's north, south, east, west. Okay, so a ship is moving this way. Ship sails 150 miles with a bearing. Okay, so now we're going to draw on the bearing northeast. That's 45 degrees halfway. 22 degrees is smaller, and you got to make the smaller this way, not this way, this way. This is 22 degrees. So northeast 22 degrees would have that angular measurement with this terminal side. So this is right here. This is 150 miles right here from the shoreline to right there. So he's in quadrant number 1. How far away is the ship from the shoreline? So he wants to know, like right here. Call that X. How far away is X to the shoreline? So now, since you've got a right triangle, you could use the pieces that you don't know, like this side. Looks like there's a hypotenuse, and there is, from this angle, what is that, opposite hypotenuse, sine. You're going to use sine of 22 degrees is equal to opposite over a hypotenuse. And then you go X equals 150 sine of 22 degrees, X squiggle squiggle. 50 sine 22 degrees. Okay, 56. Okay, the ship right there is about 56 miles from the shoreline. Okay, the key on that one, why I want to do that one is show you about the bearing. The bearing is from something to wherever the ship is. Now, if I go back over to this one, the reason why this is, you might think, well, here, this is the port or the harbor is over here and the ship's over there. If you want to know what the bearing is from the harbor to the ship, the bearing from the harbor to the ship, that would be this angle right here. Not that one, this one. But the problem is saying from the ship to the harbor. What's the bearing? Will the captain follow to the harbor? So this one's a little more complicated. I have to draw a new one. This is what I'm going to do. Draw a new bearing like this. This is my adjusted north, east, west, south in red. All right, so the bearing that I have to follow, and I'll do this in purple right here maybe, here is from the south. Okay, here's where the harbor is right there. The harbor is up in the, what is that, second quadrant? You don't want to go this bearing because the ship's not up here. The ship's, I'll take that back. You do want that bearing. My mistake. Oh, here's the other thing. Bearings are always acute. I didn't tell you that. That's the thing that was different with my pilot friend. His heading sometimes was like more than 90 degrees. That's what threw me. Yours angles are always acute. They're always less than 90 degrees, always. So you don't want from here to there. You don't want that bearing. You don't want, you want this bearing right here. See, here's the right angle right here. You don't want that one. You want this big one. Okay, so all that meaning what? What, Jeff? What? You could say, I wonder that angle right there. This is 29. This is also 87. This is 87. That's 87. Parallel lines. if I wanted to find this one, that's a tangent. If I found this, couldn't I find this one? I'll say that again. If I found this, couldn't I find that one? If I found that, I use the complementary angles to find, I'll call this, ultimately I need theta. So I'm going to do it that way. I'm going to say tangent of that funny mark. Okay, tangent of this, oh shoot, alpha. Tangent of the alpha is equal to opposite over adjacent. So that's 29 over 87. So you go alpha equals tan inverse of 29 over 87. Okay, 18.4 degrees. 18.4 degrees. So if I want theta, theta is equal to the 90 degrees minus alpha, which is 90 degrees minus 18.4 degrees, which is 71.6 degrees. So the bearing that the ship captain should take, that's less than 90, is 71 degrees, 71.6 degrees, and the heading, or the bearing, is northwest, not west-north, but northwest. Bearings are challenging, but you will find one or two. I like them because they're thought-provoking. You'll find one or two on your exam, final exam as well. The author does, I think, 2 or 3 bearings in this section, but there'll be more bearing problems coming up also in future chapters. All right, thanks for hanging in there with me. This has been a full day, longer than I normally take. Oh, let me release the make sure. Give me a moment. Release the monkeys. Math 27. Let's see. I'm looking to see the kind of problems. Graph, I see a graph, I see graph through 5. Yeah, there's only 5 problems. Only 5. You guys can do this. Not right now, but you'll have plenty of time over the weekend. So let me hit publish. And does Zinnia, Matthew, or anybody wants to do a thumb? Okay, Zinnia says yes, thumbs up. Somebody else, one more person. Little yellow hand if you've got it. You're welcome, Lily. I see. Thank you very much. Okay, Matthew says yes. Okay, looks like it's up and running. So just make sure you get it done over the weekend. And now we're done. So group quiz should be released, I think I said on Monday. So you'll have a chance to work on that till Tuesday. And okay, stick around. I've got a couple minutes before my next class if you have any individual questions.
Can you repeat the last thing you said about Monday and Tuesday? I missed it.
Sure. So Tuesday in your course outline or your assignment schedule is group quiz day. So Monday, 24 hours ahead of our class, you can probably see it under assignments. It's ready to be released on Monday. And so you'll have access to the group quiz 24 hours ahead of time. You can do what you want or none. I would do something. And then typical group quiz, I put you in breakout rooms so you can talk about it. And then you have about an hour to an hour and a half to wrap it up, because then it closes down an hour and a half or an hour after our class on Tuesday.
Got it. Thank you.
Yeah, you're welcome. Well, there was a lot of chat, 33 chats. Wow, 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 wow. Let's see, what was Snapchat, Snaptraps, milkshakes, calories. Well, people are giving phone numbers. Okay, that's fine. Snapchat, work after class compared tomorrow. Everybody wants to get together. That's good. Does anybody want to work on it after class? Good. Cool. Okay, that's good. I'm glad you guys were discussing. Okay, so I got a few minutes. Questions? Matthew, it looks like you're ready to ask.
Yeah, sorry. Just because I have to ask this stupid question again because I forget every time. The group quiz, that's the one where you have to take a scan of our work and our answers.
That's it. That's it. That's the one.
Right.
The baby quiz for you guys, though, the few of you that are here, the baby quiz, there's only 5 problems. Those are multiple choice. You just click, 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 click. The one over the weekend. But on Monday, when that other one gets released, that's the one that has about, I don't know, maybe 10 or 12 problems. And then you'll pick some of them to turn into me. And then you'll scan those answers to me. So yeah.
Sorry, when are you gonna release the baby quiz? Oh,
I
you
just
just
did. I just
sorry.
did.
Oh, you just did. Okay.
It's number 7. I think it's, I know I call it baby. It's called Daily Quiz number 7. Just check it out, Delia, see if it's there.
Okay, I see it.
Okay.
Got it. Thank you.
Yeah. Anybody else question before I leave? Okay, you're still chatting. Okay, still chatting.
All right, thank you.
Okay, Sam, you're welcome.